what exactly is Hadoop, or where does Hadoop exactly fit in this whole enterprise. Let's first talk about that, and then we will talk about today's agenda. So our first point is that maybe if the questions would be, what is Hadoop? We'll answer that, but more importantly, where does Hadoop really sit in an enterprise? Let's first answer that particular question, and then we will take up the next part of the question. So let's start. Okay. So let's start with a very small story, and we should be good to go with. I am Jeff Bezos, CEO of this e-commerce site called as Amazon. Okay. So my name is Jeff Bezos, and I'm the CEO of this site called as Amazon, and you guys are my technical guys. As of today, our organization looks like this. As of today, our organization looks like this. We have our e-commerce site, and that runs out of Oracle. We have our inventory, and that runs out of MySQL. So life is all good. Everything is nice. Now, if I want to answer a question, how many iPhones should we order next month? Very simple stuff. How many iPhones should we order next month? Now, to do that, a typical way of doing things would be you loading this whole thing to a warehouse via Teradata, and then you basically do your reporting. That's where you have tools like Tableau, ClickView, and I'm sure you guys are already aware of this enterprise piece. So all your data gets generated, you load in a warehouse, reporting is done. Life is simple. There is only one problem. The real problem in this whole setup is that this works very well for, let's say, 2000 or 2005. Today, we are in 2017 now, and our questions are not that simple because the amount of data that we are looking is very, very huge. Now, let's take a simple example. If I was to change a question and say, let's take a simple example that as a CEO, I want to know how many people bought iPhone, they really loved the phone, but they hated the delivery. And instead of talking to us, they went on Twitter and they basically vented out the frustration. Let's take a simple example. And some of the other questions related to, data which is fairly big. Now, first thing is that data which is coming from sources like Twitter and maybe a lot of other sources like your sensors, your network logs, your firewalls, data that's getting generated is really, really huge, and it's not going to fit into your traditional database-based systems. Okay, so that's where you decide to bring in another system, and this system is called as Hadoop. Now think of Hadoop as, think of it in a very crude way as a big data warehouse. It can take data from anywhere, can easily host a single master and theoretically tens of thousands of nodes. Can give you two services, store and process. So this guy can get data from here, plus it can get data from other sources like social, network networks, firewalls, structured, unstructured, blah, put a blah, and go ahead, put one more blah. Can be any other source. And this guy can actually get data from here also. Now, this guy can let you store the data and let you process the data. Okay, let's let you store and process the entire thing. So think of Hadoop as somebody who complements your warehouse typically to store a lot of data, and then you can store and process. Now, after you store and process the data, whatever final processing is done, you can load that final thing in a warehouse, and that's what is a lot of times called as analytics. And you are free to directly connect a reporting tool also. That is also possible. That's also absolutely possible. So it's direct connectivity is also there. So based on your pattern, you can choose what you really want to do. That's the idea of Hadoop. Okay. So you put all your data at one place, cheap storage, and you can have store and process, and whatever comes out, you can load it to a warehouse, or you can directly connect reporting tools and do it. There's one more use case where whatever you learn inside, if you load it back to Oracle, man, this becomes recommendation engine. This becomes recommendation engine. Think of it this way. From all the sources that we have got our data, we learn that 85% of people buying iPhone buy a screen guard, and 81% people, they buy a back cover, and let's say some other information. Now once we learn that within Hadoop, we load it to Oracle, and when the next customer who comes to our e-commerce site, we can always show them that people who bought iPhone also bought screen guard, back cover, blah, blah, blah. That is also possible. So think of Hadoop as a big data store. It can store the data, can process the data, and then you can use the data the way you like. Now, why this diagram is important? To tell you that our entire session is going to be focused on this blue box. We are in this particular class to learn about this blue box. Okay, so over the next couple of sessions, while I'm going to take this for you guys, what we are going to talk about this blue box is what is Hadoop, this blue box. How does store work? That is nothing but HDFS. How does process work? Nothing but MapReduce. And how does some other tools on Hadoop work? So we are in here to talk about this. How does Hadoop store data? How does it process data? And some tools on top of it, and some tools on top of it. That's exactly what we are going to do. Okay, so hope everybody is clear. Now, can we zoom this diagram now? That means we focus on the blue box, and can I redraw this blue box as Hadoop is this giant system that gives us two services in the game: store, process. And what it consumes is big data. So it takes all my big data, it lets me store the data, and it lets me process the data. It lets me store the data and lets me process the data. So this is exactly what Hadoop is all about. Can let you store the data and let you process the data. Hadoop is this giant system that says, okay, bring in the data, I will store it for you and I will process it for you. Bring in the data, I'll store it for you and process it. Okay. So now, if you really see, for most part, if I was a student, probably I would have this question right now in my mind, that probably so these are really two questions that will haunt me right now, that okay, you're telling about Hadoop is some system that will give me storage and processing. How does store really work and how does process really work? So let's get into that right now. Let's get into that. So there are two questions that as a student probably will come to my head, that okay, yeah, he's talking about Hadoop is some system which is store and process. Okay, cool. How does store really work? How does process really work? If these two questions get answered, then I'll be probably clear that what Hadoop is all about. So let's jump onto that. Let's jump onto that. But again, instead of just doing the names of the processes, why not take a small story? Because that way we will really have the entire understanding. So let's take a small story. So I'm using some imaginary name. So let's say we are TCS, Tama Consultancy Services, forgive the spelling, and we have presence in 150 countries, and let's say people love us. Just yesterday, our Facebook page got 1 billion likes. So our Facebook page has got 1 billion likes. Okay. So let's build this story, guys. Focus on the story, because once you get the story right, you know, this solve questions about, oh, name, node, this, then everything will get very, very clear. Focus on the real story. Just focus on the story. So we are Tama Consultancy Services. We have presence in 150 countries. People love us. We've got 1 billion likes on Facebook. Our CEO, Mr. Kailash, is really excited and wants to see a very huge dashboard where he sees whole globe. And based on hovering on each country, he will see the number of likes. Okay. So in 4 days time, Ajay is supposed to get this dashboard made. So now what happens is, let's say Ajay wants to use Hadoop for this. Let's just say that. So Ajay has two members in his team, Mr. Admin and Mr. Developer. Now Ajay tells Mr. Admin that, dude, go set up Hadoop cluster. And he tells Mr. Developer that, listen, you are supposed to develop this whole dashboard. Okay. So let's see what happens right now. Let's see what happens right now. So now the story begins. Ajay has 2 people in his team, and those 2 guys are now starting to do the business, or they are getting about business. So let's see what that's. So first, admin comes in, and admin purchases 5 machines. Admin purchases 5 machines. Okay, where admin decides 1 will be master and 4 will be slaves. So Mr. Administrator has come to work and is setting up a 5 node cluster, 1 master and 4 slaves. And Hadoop is all about storage and processing. So on the master he installs somebody called as storage master. And on the master he again installs processing master. Okay. Now on the slave he installs storage slave, and he installs processing slave on the processing master, a processing slave. So on all slaves he's installing this. Now admin tells Ajay, boss, setup is done, go ahead, ingest data and write program. So now Ajay calls Mr. Developer and says, Mr. Developer, go ahead and please write the code. So first developer has the code data. So developer takes data, which is let's say facebook.json, and let's just say that the file is 640 MB. Let's just say file is 640 MB. So when it writes to storage master, actually the file is broken into blocks of 128 MB. So 648 divided by 128 means 5 blocks, and each block is replicated 3 times. That means 15 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let me write the calculation. So 128 MB is each block, and 3 is the replication factor. Okay. Now the data is already broken into it, and the storage master actually just has the metadata. The metadata looks just like facebook.json is nothing but block 1, 2, 3, 4, 5. Let me change the color here. So the metadata would look like facebook.json is block 1, 2, 3, 4, 5. Block 1 is present on slave 1, 2, 3. Block 2 is present on slave 2, 3, 4, blah, blah, blah. So this is what is stored in storage master. There is no problem of memory because master is storing only the metadata, not the data. And when the data is getting transferred also, data is not passing through the master. The client will directly connect to the slave. Now because of that, the memory is not at all an issue. Because of that, the memory is not at all an issue. That's the real idea. That's the real idea. So irrespective of how big file you write, okay, it just goes through, uses the memory of name node for the metadata, but the data is returned to the what you call slaves. Now let me just give you a simple example around this. Let's just say there is a project manager who has 4 people in his team. Now project manager just knows what tasks people are doing, but all the tasks are done by the slaves. So that's why manager is not a bottleneck. Neither is his capacity to know which task is running where is a problem, because he's just knowing what is running where or what is stored where. It's not about doing it. So manager is doing nothing in this. He has the metadata. That's the idea. Okay. Now your data is stored. So developer took the data, he writes to storage layer, and all the data is spread across and done. Now the developer writes the program. And because we want by country, let's say it is group by Java program. Let's not complexify it, just it's a Java program. Now this Java program gets submitted. The processing master will copy this code on every machine. And that's internal, so it's not our business how it's done, because it's a framework. So you submit to the master, master will push it to everybody. Now, what master will decide is, master will tell that, okay, listen up, Mr. 4 slaves. Slave 1, you process block 1 and 2, which is local to you. Okay. Slave 2, you process block 3, which is local to you. Slave 4 or slave 3, you process block 4, which is local to you. Slave 4 process block 5, which is local to you. So do your business locally, don't talk to the network, and the job has to be done. And then you get your final output, which can then be, directly shown on a reporting tool, or you can load it to a warehouse and show the whole thing. Now this is how Hadoop really works. This is how Hadoop really works. Okay. Now don't worry about the process names. That will come in the next slide. Right now just focus on the concept. The concept is simple. Write data, cut into pieces, spread it across. Write the program, spread it across, and do it locally. That's about it. That is how Hadoop really works. That is how Hadoop really works. Okay. So this is Hadoop for you. This is Hadoop for you. Now let's quickly get into the process names, because once we get the concept right, it's about understanding the process names. Once we get the process names, we'll be ready for the next things. Okay. So guys, before I proceed, the next diagram I'm going to draw is the most important diagram of this session. So please get this right, because this is, you can say, heart and soul of the whole session. Tighten your seat belts, you got to get this diagram right. Okay. So far, let's say the trainer has been talking about Hadoop gives you two services: storage and processing. Wow. Now let's get into names. The team that gives you storage is called as Mr. HDFS. The team that gets you or lets you do storage is called as Mr. HDFS. This is the team that lets you do storage. The team that lets you do processing is called as MapReduce. Now again, it's a master slave. So the master in HDFS is called as name node, and the slave is called as data node. In MapReduce, the master is called as job tracker, and the slave is called as task tracker. Simple stuff. So storage, the processes are HDFS, the team is called HDFS and has two processes, data node and name node. For processing, it is job tracker and task tracker. So life is very, very simple here. Good. Now, this particular setup had one very serious limitation. This particular setup had one serious limitation. So this setup was called as Hadoop, good, but this had one serious limitation. You can only write programs in MapReduce. So whether you like it or you don't like it, you will only have to write programs in MapReduce or any other framework that runs on MapReduce. But you can't have anything else. Take a simple example. You can't, let's say, use Spark for that matter. That's a limitation. Let's take another simple. Let's take a real world example. This will make it clear. So make sure you get my question right. Let's say I'm a layman. When I say layman, it's a proper layman. Okay. So let's not argue into technicalities. I'm just an ordinary Jack who runs, let's say, a burger shop or a coffee shop. Now, there is a problem in my iPhone battery. There is a problem in the battery of my iPhone. Can I just buy a new battery and put it in iPhone? Can a normal person walk into the store and buy battery for iPhone, open iPhone, plug it in and it's done? No, it's not. Why? Because Apple tells you that, listen, if you want to use my phone, you will have to use my battery. You like it or you don't like it. You can't take any other battery from the market and plug it into iPhone. Very similarly, if you wanted to use Hadoop, Hadoop would say, listen, you're welcome, come use it, but you will have to express yourself in MapReduce only. That was a serious limitation. That is why it was called as Hadoop 1.x. It was called as Hadoop 1.x. What you really wanted is something better. What you wanted, it is generalizing it. So that's where I decided to come with another version of Hadoop where you had storage, which was same, but instead of MapReduce, you bring a new component called as Yarn, which is nothing but resource manager and node manager. Now what Yarn would do is, it says I will give resources to anybody. I can give resources to anybody. Or be it MapReduce and be it Spark or be it others. Doesn't really matter. Okay, doesn't really matter. What happens right now is, with Yarn, if I was to put in one word in Hadoop 1.x, but in 2.x, so guys, the keyword here is, all I want you to remember is, in 1.x, MapReduce is the only way. In 2.x, MapReduce is one of the way. It is one of the way. Now, this course is all about 2.x. We are not discussing 1.x here at all. Now, the reason I explained you 1.x is like, can I explain good health without explaining bad health? Probably it's going to be tough. Very similarly, if I have to explain 2.x, I should first show you 1.x and the serious limitation there, and that's where you bring in 2.x. That's where you bring in 2.x. So 2.x is a generic resource manager which says everybody who needs resources, come, I'll give you the resources so that you can do the job. That is how 2.x really works. Okay. So this is Hadoop 2.x. Now we'll do one more slide, one small slide, and we will go ahead and take up the questions. So now later we'll introduce other components, but right now you got to get this one right, that why Yarn is there. Now, so the question would be, how does this diagram change? How does this diagram change with 2.x? So I'm going to remove everything that is there and we'll slowly put one by one, because you've got to understand this. So right now there is nothing. I just have storage layer. Okay. Now here we will have Yarn master, which is called resource manager. Don't worry too much about names, because you will eventually, once you're out of this course, you'll be a champion at this name. So you don't have to really worry about, don't clog your head with too many names right now. Just keep it simple. Keep your life simple. That will be good right now. Just understand, okay, there is Yarn master and Yarn slave. So you're not going to a war tomorrow morning that you should remember all the terms. So there is storage master and storage slave, and there is Yarn master and Yarn slave. But I have not added anything else. So there is Yarn master and Yarn slave. The names are resource manager and node manager, but don't worry too much about them. They are somebody, it's fine. You'll figure this out. So my storage layer remains same. I write my data, it is processed, all that is fine. But when I submit my job, to Yarn master, Yarn says, so let's say this is a MapReduce job. Yarn says that, hey man, I don't know how to run MapReduce, but I know a guy who's called App Master. Okay, he can do MapReduce for me. So I am the resource manager. I only give resources to people. So I don't understand how to do processing, but I know another guy called App Master. He will do the job. So now Yarn will initialize an App Master on any one slave. So let's say Yarn will initialize an App Master here. App Master is a process that will do the job. So who's responsible for the job? It's MR App Master, not Yarn Master. So Yarn Master says, oh, Mr. MR App Master, there is a new job for you. Why don't you do it? So now App Master will go to Yarn Master and say, boss, if you want me to do this job for you, if you want me to pull this job for you, please give me following things. Give me 2 resources on slave 1, 1 resource on slave 2, 1 resource on slave 3, and 1 resource on slave 4. Why? Because data locality is important. So Yarn App Master says, okay, go ahead, take the resources, and MR App Master will now go ahead and fire the job everywhere. Like this, if you submit another job, there'll be another App Master who will do the job. So the idea here is that Yarn Master does not do the job. It only gives resources. MapReduce can ask for resources. Spark can ask for resources. Impala can ask for resources. Anybody can ask for resources, and you are good enough, or you are ready to just go ahead and do that. That's the real idea. So this is Yarn for you. There is one important thing I want you to remember as far as this whole detailing is concerned. If you are clear with one thing, everything else will fall in place, and that one keyword is, in 1.x MapReduce is the only way, in 2.x MapReduce is one of the way. Why do you need to go for 2.x? Because you want more options in life. Simple as that. Simple as that. So think of it, I'll give you a simple example of, so there's this company called Foodpanda. This company called Foodpanda. So Foodpanda is a company that does food delivery for you. Now, If you just go to Pizza Hut, you can only call Pizza Hut or McDonald's and get delivery only from McDonald's. But if you call Food Panda, you can basically order from any restaurant that you really like. So think of Jan as Food Panda, who says, listen, I don't make food, but I can always provide delivery services for people to do what they want or have what they want. That's the real idea. That's the real idea. With this explanation, so I'm not introducing other components of Hadoop. With this explanation, our entire landscape of Hadoop from the architectural working perspective is done.